Welcome to ScalaUA conference.
Committee and said, yeah, this talk is intended for intermediate beginners, and intermediate was left in the program and beginners disappeared. So actually I think for you who think they are already intermediate, it won't be much of interesting stuff here present. Yeah, okay, shall we start? Just I will let people left. Okay, let's go. So my name is Slava. Today I am here to talk about ScalaCheck. So if you will do something like that, like go to Google and say, give me videos about ScalaCheck, you will encounter dozens of them. So why I'm talking here? The reason is like they all are similar in the sense that they detail, they speak about theory and not very much of practice. They speak about examples like testing strings, testing numbers, testing lists, and so on. So, and the moment you burning this idea to use ScalaCheck in your real project, you go to your daily work, and all of these are tested already for you. So now I think we can do the following. We can program the game, just a very simple game. Probably most of you played this in the school. Can you see this? Like you have a playing field, a board, and multiple players. The players can draw the line, a single line connecting dots. Here you probably cannot see the dots, but it's like an edge of a single cell, and then the next player can draw the line, and so it goes until player can close the cell. Then it belongs to the player, and the player keeps the turn. So it goes until we have the playing field full, no empty cells, and the winner is who has most of the cells. So I suppose, or I suggest we program this in the next 40 minutes using ScalaCheck. Who already knows what ScalaCheck or property-based testing is all about? Okay, just for those who don't, we have such software which is able to test different testing configuration for us. It consists of the generator, which generates this data, the checker, which executes the tests, the property which we formulate about our system, what we expect our system to do and what not to do with the test data, and the shrinker. And the shrinker is kind of the component which takes all of the test data which was generated, and if the test fails, it just tries to find the minimal data which will let your property fail. So the property just any input which is true or false, the random input of the generator, and the minimal input of the shrinker, they all fit to the checker, and at the end you have your properties run and your system tested. So that's too early for that. I will close the slides and go to the... So that's an SBT console. I think it's cut a bit. Oh, how unfortunate. Okay, maybe I can. Yeah, I will try my best to show everything to you. But if you probably won't see the right side completely. So I will start to create by creating the specification, like that is we're done, importing ScalaCheck packages and creating the initial specification. So we can save it and we can run our tests. And we're done. Yeah, everything's successful. We didn't formulate anything yet, so let's try to do this. I would start with formulating a property for the game itself. So like I said, for the game, we need that in all of our scenarios. We have a board and we have some players. Yeah, we don't know what they are. But what do we expect, right? We probably will say like we have winners after the game. We apply a game to our board with players and we expect to have some winners, and then we say, okay, winners play the game. So we don't want to have anybody who didn't play it and won, right? So, and we say like, if we div players and winners, then they should be empty. That's one. In the end of the game, we do want to have all cells taken. Like board should have some cells, and for all of them, they should be empty. Right? There's a problem here. Like I write the board, but if we program this game in a functional style, then the board should be mutable, right? So we probably need the end state here. And some end state, but yeah, we can do better. We can just have a log. Like any change in the game board, we will remember and have it at the end. So that's how we formulate the expectation about our game. One more, like we want winners to have most of the cells, like. For any winner, we say results for this winner is maximum result. Results, where is max? So that's all of the properties we can say about the game as a whole, like all of them should be true. If we now go to our console, then the compiler probably will say, I don't know what to do with that. I don't know what the board is, I don't know what the player is, I don't know what the game is, and all of this stuff, right? But I would suggest we just continue and say our expectation about the rest of what we are trying to do. Like, as I said, we will have players making turns. So we again need a board and the players. And then we say, okay, we have a new board or changed board and new players. And we say, after the turn with this board and with those players. Right? And what do we expect? We expect that, okay, let's say, if player has took the cell, that means that new board results are not equal to the results of the old board. And in this case, we say, okay, we want to have all of those properties to be true. Let's start. Player keeps the turn if it took the cell, and we formulate it with ScalaCheck like cell taken. And in this case, we expect that new player list is equal to the old player list, right? If the player didn't took any cell, then it loses the turn. New player on next player's turn. And it's the opposite. If no cell taken, then we expect that in new players list, head will be the one which was the second in the old list, and at the same time we say that the first player will be the last one in the new list of the players. So what else should we expect from the turn? That's one of them. At least one of them. So what else should we expect? I would say that we expect that we don't allow a player to skip the turn, like at least one cell is changed. And it looks like board cells shouldn't be equal to the new board cells. And player, in one turn, any player cannot take more than, cannot change more than 2 cells. Why 2? Because if you kind of make an edge on a cell, then you change an adjacent cell as well, like if it's not a border cell. So at most 2 cells are changed, and in the same way we say, okay, that's new board cells is diff from the board cells, and the size of it is less than 3. And now we say, okay, all of this should be true for our turn to make sense. Now if we switch to the console, we have even more. Oops. Yep. Stuff from the compiler. Like the compiler doesn't know what the cells are and so on. Okay, let's. I would say I kind of formulated everything I told about the rules of the game, so it's time to make the compiler happy. So first of all, we say that's our game. It's of type game, something. And then it's a turn, it's of type turn, and it's something. What else do we have? We have players and the winners and the board. Let's just make them. Players, the order of players is important, so it's a sequence. The order of winners is not, so it's a set. So the board should have some dimensions, which and height, and the cells itself, like cells, it's a sequence of cell, some cell. Let's define the cell. The cell in our game would be, let's it be a trait. And it should have some edges, which is a set of edges. And it might have an owner. Like that. So we just want to have a player. Let's define a player. To differentiate, let it have a color. And we need the definition of age. Let's model it like an ADT, like bam. 4 of them, top, bottom, left, right, and all of them, like definition. So now we kind of defined all of the types we used here. We still miss the game and the turn. Okay, let's just think that what is a turn? It's something which takes a board and the players. And actually it returns the new changed board and the new list of the players. And the game, it's something which takes again the board and the players, and it returns, what did we said? Winners and the log. And a log. And what is a log? It's just a sequence of boards, right? Yeah, I guess we still miss some definitions in the board. We used here like cells we have defined, what didn't we? Results. And let's do it. The result would be a map from the player to the count of the cells it owns. Let it just be empty for now. We will define it later. So, do we have everything? Is the compiler happy? No, it's not. So, there's a typo here. That's a players. What else do we need? Can you see the font? Make it smaller. Is it okay now? Still? Okay. So what do we have here? New board, new players, board, players. New players, players, new players, players next, new players. That's board cells. New board, board. Should be correct now. Yeah, we need a definition of an empty cell right here. So let's define cells. For now, we just have a trade, and obviously we will have some full cell which is owned by the player. Full cell with some player. And the owner will be some player, and it will have all edges, and another flavor is an empty, which has some edges. And let it be empty by default. And it's known. And we still miss the definition of empty, right? It's like that. So what do we have now? I guess here we mess with sets and sequences. So for our definition of winners, we need to convert players to set. And we need to know the results of the game. Here we used the board result to compare if that cell was taken or not. There we have it. Why isn't it working? Whatever. I will move the definitions we already made into the separate space, just to have it easier to navigate. Oops. And I will import them here. Another typo here we have edge. If you take a look, you will see here that ScalaCheck complains that it cannot find implicit value for parameter arbitrary board, right? So why is that? The problem is that, as I said in the beginning, we need the definition of the property to describe our system, and we need the generator for the test data. So obviously the ScalaCheck doesn't know how to generate a random board. It has some embedded generators for embedded types, but for board, of course, it's not, and for players, it's the same. I will just define those generators and make it happy. So we will start with players, and we will use existing generators, one of NC colors. So that the existing gen one of just takes one value of the existing collection in random player, and we just yield the player with the color. So now we need a list of players. So we will do this like first we need to know how many. And we let ScalaCheck choose between 2 and 6, just because. And then we have players. It's a list of n. Here's the number of players and the generator which is used to generate a single player. Easy, right? So we have the list of our players. So now we need to generate the board. Let's make it variable. Let's say it's min and max size of the board, and it's okay. Let's say we need dimensions the same way like we did before, and let's just for now generate an empty board with those dimensions. Oops. Yeah, the board, we haven't defined how to generate an empty board. I will just teach it how to generate itself. That's our board. We say this. And yeah, I will define just cell constructor, which is a by name parameter which generates some cell. And by default, it's an empty cell. And we call the normal constructor with the same dimensions, and we fill a list with those empty cells, or whatever we have in the constructor. So let's take a look. So the empty cell, it seems like it doesn't accept this set empty parameter. Let's define a constructor. Like that, and then we need to call the constructor here. Let's take a look. So we still have a problem here. The result is not a member of PBT jam. Results, yeah, thanks. That wasn't the specification, right? Here. And yeah, now all of those properties, both of them, they say cannot find implicit value. We defined our generators, but we still not using them. So there are two ways. We can use them explicitly like that. Board gen for boards from 2 bis 20, and then players gen. or we could use them implicitly by defining arbitrary value like that, this arbitrary, but I won't do this just because we don't have enough time for that. So let me copy paste all the stuff. Let's take a look what we will have. So no tests were executed. So we have two filing properties now and huge amount of output. I will just clean the screen and do this one more time. And then explain what happened. So the argument 0 is this one, the board. And it's a board of dimensions 8 to 16 filled with empty cells like we defined. The argument 1 is an empty list. What is that? Oh, sorry, right. And argument 1 original is a list of 2 players. So we had here, for one, we have player 3 2 times, so we need to be careful how we generate them. We don't want the player to have 2 turns. The second point is that the test failed for this list of players because we don't have any implementation yet. But the ScalaCheck knows how to shrink lists. So our shrinked list is an empty list, and we didn't define any shrinker for the board. So because of that, the board is just represented as a whole. And the same for the turn, right? So now we have 2 filing tests. We defined the filing tests. We can start to implement the stuff, I would say. Or at least something. So I would suggest we start with the turn because we cannot implement the game without having the turn implemented. And we said we have a board and the players, and then we need to return something. So we say, okay, how do we start? So we have. So first of all, we say, okay, the next player is a top one. Then we need to make a move. Okay, let's say that we have a move which the player does by applying some strategy to the board. So now we have strategy, and we need to apply this to a board, and we need to have a move. Okay, let's define what's a strategy and what a move is. Like we said, strategy is something which takes a board and returns a move. And probably a move is something which has some coordinates on the board and an edge which the player wants to set. So we now have a move, and we can apply it to some board by some player. And what does it mean? Yeah, actually I would just teach the board how to update itself by the move. The move is just updating the board. Update the board by itself and by the adjacent move. Just to have both of the cells on both sides of the edge updated. So we need to know what this adjacent is, and it's yeah, that's just another move on another side of the board. So if we have a top edge, then we go one up. For the bottom, we go one cell down, and the same for the left and right. So now we have some logic. How can we test it without duplicating the code? Like, just think about how can we test this without programming the same in the test. Actually, it turns out it's not so easy to do. We can just say the property of this adjacent move would be that if we take adjacent move of the move, it will be the same cell, right? So we just say m adjacent. Adjacent should be the same move. So we need a generator for the move. Let's define it dependent on the board, and it will take a board. And it's actually quite easy. Oh, sorry. So we just say, okay, the x would be choose 1, 0 on board, h minus 1, and for like that. And then we just need an h, and an h will be gen 1 of. Does it make sense so far?
Yeah.
So we have our move generator. So here we must wrap it all into the board generator. So we have for all boards, I will just take this one. And we have our board. And then we have for all move gen is this board, our property, closing, so some typos of course. So in the game it says 64. Yeah, strategy of course. We now define the strategy of the player here. So we're using this strategy. Let's just finish it. So now we have a move. What do we do? We say the new board is just a move applied to the board by the player, and then we say, okay, if new board results is not the same as an old board results, then we return new board and the same list of players as before, because obviously a cell was taken. Else we return new board and the player has the last turn then. So that is for the turn. Now let's fix our player. The player must have a strategy now, so where is its strategy? And now let's see what happens. We need to define the board update, of course, and yeah. So the board needs to know. Let's define the results first. So for the results, we just take all cells, and then we collect all of them which are full. And then we take the owner, and then we say, okay, group by identity and map values by the size. So effectively, we just collecting the number of cells for each player. So we have this now. We now need to define an update, and for this we need a move and a player. And yeah, that will be now a little bit complicated because we need to know if the move is correct or not. So let's just say that the board is a rectangle of cells. And the move, it is a point in this rectangle. So now we can operate with them easily a little bit. So we say if the move is inside of the board, and we do something else, we return just the same board, not changing it. And that cell itself is, we just look for the cell for this move and update it with the move. So we will need to teach cells how to update themselves and this player. And then we return new board with the same dimensions and update it. Cell. Right, so now cell needs to know how to update itself with a move and a player. And for the full cell, it's easy, right? It's just nothing happens. For the empty cell, it's a little bit complicated. So first of all, if edges contain the age we want to change, then we do nothing. In the case, if we already have 3 of them, then we obviously will need to turn this cell into the full cell with this owner, and else we return a new empty cell with edges extended with this edge, right? So let's ask our compiler what we are missing. Cells updated. Okay, I forgot. What did I forget? Found sequence any required sequence itself. Something. Sorry. Okay. There's nothing in this warning. Let's walk over it once again. So if you want to update something, we need to define a type here. It returns itself. And we have typos here. If new board results doesn't equals old board results. What else? And found very player. Players. Yeah, players. Yeah, so now we find with our implementation, now our tests are just failing because we have the color defined in our generator but no strategy. So, and now just see how easy it is to extend something with property-based testing. We say just strategy, one of strategies, strategy all. And that's it. That's it. Yeah, of course we don't have strategy all yet, like that. And that's just a lot of typing, so I will save the time to define that. Yeah. So the logic is here, like very simple in the core. Just a lot of code. So just imagine, just think how would you play the game. You would probably have different strategies for yourself. Like if there are some cells which can be closed, you will choose those first, and then you will look among others. And so this is the logic which has different strategies of different priorities, and it combines them in order of priority. And there are different of them, like random strategy, which chooses any cell, or strategy which avoids to place third edge, or strategy which always closes cells, or full strategy which combines them. So that's basically all of them. They're quite primitive. They just take a cell and say if it's okay to take this cell for the move or not. So let's look at ourselves, our tests. Where was? So now we see our move tests, they are pass. So it seems like this property holds for any possible move and any possible board of this size. For the turn, we have some exception. Let's look what this exception are. No such element exception head of an empty list. What's that? So we say, okay, for our property turn, we generate some players, and then in the property we say, okay, the second player in the list should be now the first one, but we have no guarantee that there will be two players in this list. So let's just constrain our generator, and we say such that any list which it provides should be of size 2 at least. We have our turn which passes. Congratulations. So now that's kind of, we are finished with the turn. We can now implement the game itself. So and we have a board and players, and we need to return a winners and a log. And in the very beginning we don't have any log, so I would suggest we say like it's a game 0. This is a board. And a log containing our first board. And the game 0 is then something which takes a board and the players and the log and returns the winners and the log. And how can we define that? Board, players, log. So we say, okay, if board results various sum is equals. Yes, if we have the results various the same number like boards cells, which will means we have all the cells taken by somebody. We just return our players and a log. If not, then we say, okay, we have a new board and a new list of players as a result of turn applied to the board and the players. And we can continue with this new board, new players, and the log is an addition of the new board. Does that make sense? Okay, let's see. Something is wrong with our new players. Let's take a look. Not found for new players.
B.
Okay, thanks. Yep. We called P here as well. Saved it. Yep. The same mistake. And what do we have? So we have our turn still passing, we have the move which is still okay, and we have a game which is not okay. Why is that? no such element exception head of an empty list. So we probably need to constrain our players in the same way here. And we still have the same problem. Okay, not found. Okay. Yeah, we probably have the actually that's not right. What I'm doing here, we cannot return just return the players, right? Because that doesn't make any sense. We need to return board winners. And now we need to teach the board how to find the winners. And the winners is actually just, so we take results and we collect players and number of cells, and we just say if number of cells of the player is equals results values max, then we take this player. So those are winners. There might be many, and if the winner has the amount of cells which is max, then it's a winner, and we convert it to third. Results. And probably for the results we still need to define this default value as 0. So somewhere I'm doing something wrong. And it looks like what I'm doing wrong is in some function of the strategy. In some function which tries to read the results from the board. So like it's here. So let's do just otherwise. We just say, okay, if board cells filter is empty. Can anybody spot the mistake?
No.
So, given that our turn is working, that is something which is connected to the implementation of the game, definitely. So let's see what we're doing here. We're using cells and filter, so it kind of cannot be wrong. Maybe we're doing something wrong with winners. Yeah, it looks okay.
Strategies.
Yeah, I don't think so. The strategy is just part of the player. Yeah, let's just try again with this default value. No, that didn't work. Empty max. Okay, let's see where we're using max. Result value is max. So we obviously doing wrong thing here. We kind of using the value as max before making a turn at all. So let's check our implementation of the property here. So what are we doing? We have here players to set. We're using here board results, right? But we cannot do this because we need to have our last board, which is a log last. And then we have our last board here. And we have our last board here. And let's see what will happen. Nothing good. Have I missed something? Last board results of the player. Is this one failing? No. Yeah, this was the second one. Last board cells for all is empty. I don't know why. I will just try to delete it to save the time. It didn't help. And this was the first one. This looks like a problem with an implementation. Okay, I will cheat. I will just say yeah. Does it work? And now something else is not working. Yeah. Let me just really cheat. Oops. Yeah, okay. The reason is I just made some last minute changes. So this trade rectangle now does take type parameters, which it shouldn't. So I will just remove, which wasn't here before. That's the game, how it's played by the ScalaCheck in background. So as we define our properties, we actually just saying for ScalaCheck, do this exactly what's happening as we're not seeing that. So basically what now happening, I just put the log statement in the property of the game here to print out any step in the log, and that's what ScalaCheck is doing for us in the background. And what's cool with that, you actually can define very complex properties. Like, for example, if you need to say which strategy is the best one, you can do this easily. For example, if you say, okay, you generate boards and players, and then for the player we generate random strategies, and then we let them play, and then we decide for ourselves which one should be winning strategy. For us, it's the most. So we just took the place in the collection of all strategies, and the strategy with higher index should be winning. And then we compare them, the strategy which is actually winning, with the strategies of all players, and we say, okay, winning strategy should be on the top of the list. Yeah, if I remove this logging statement here and just run the test again, then we can see that I'm using the collect statement of ScalaCheck, which is doing following. It collects for all of the test runs winning strategy and the maximum strategy used for the players, and then we can see, for example, in half of the cases the max strategy was the third one and winning. In the quarter of the cases it was the second one, and the second one won. And 30% of the cases we had actually the superior strategy, which has lost to the less intelligent, and that probably because the strategy which was worse took the first turn. And we can also use collect the test data like that. No cell taken, cell taken, and that is can be done using classify statement. Just like we decide if it's like before, I cheated. The cell taken means the results are changed, and then we just say, okay, we want to know how many cases was generated by ScalaCheck for each of those cases. Yeah, that's it. Thank you very much. The code will be in GitHub if somebody is interested. Thanks. Do we have time for questions? Yeah.
Business logic or some enterprise things that can be tested.
Yeah, that's the problem is like they're very different, and there is a lot of facilities in ScalaCheck to do just that. For example, to generate case classes like I did manually now, you can use a shapeless plugin for ScalaCheck, which will generate random case classes for you for free. You can test stateful systems with ScalaCheck as well, but it's just impossible to show it in 40 minutes. My goal was just to demonstrate how easy it is to build something, this property-based driven approach, and how flexible it is in the case if you need to change the code, in contrast to the unit testing. Yeah, for business, for example, the best example probably I can name is Akka. They use ScalaCheck extensively for their logic.
And maybe cuts and so on.
I don't know. Just I'm not sure. If you know that they use, then yeah, I'm not sure about that. Yeah. Then thank you very much for your time. Attention.
I guess I've seen a lot of young people, smart people, in the Steve Jobs sense, hungry people, and I would say just stay like that, stay hungry for knowledge, stay smart.